So in this final review, we are going to practice our parent functions and remember some stuff from 6.8. So the first thing we're going to start with is our paper on this side, and we are going to practice our 6 parent functions. So the first one is absolute value of x. Absolute value of x has a starting point at 0, 0, and then its growing pattern is over 1, up 1, over 2, up 2, over 3, up 3 on the right hand side, and on the left hand side as well, left 1, up 1, left 2, up 2, left 3, up 3. And we could continue going on that if we needed to, but I think that's plenty. We connect those ordered pairs together and draw a straight line with an arrow on the end to show that that goes on forever. And the domain on this, pardon me, the domain for any of these we get from going from the left to the right. So as I start from the left, I see an arrow pointing to the left. That means infinity. And on the right, I also see an arrow pointing. So that means infinity as well. So the domain for this is going to be all real numbers. Or if you're lazy, you can do a capital letter R with a line through it like a dollar sign. The range we get from bottom to top. So bottom of this looks like it starts at 0 and then it continues up. So range is y, and I need to say from 0 and above. So it begins at 0, but it's above 0, so it's going to be greater than, but it also touches 0, so it's going to be greater than or equal to. The next one is x squared. It has the same start point, 0, 0. But then if I put 1 in and I do 1 squared, I get 1, which is the same. But then if I put 2 in and do 2 squared is 4. So it jumps up to 4. If I put 3 in and I do 3 squared, that gives me 9. Same thing on the left. If I put -1 in, -1 squared is 1, -2 squared is 4, and -3 squared is 9. This makes a U shape, so we need to make it a nice smooth curve. It should be rounded at the base, not an angle like this. Okay, so domain on this one, left arrow, right arrow, so all real numbers. And then range is the same. It starts at 0 and as everything above, so y is greater than or equal to 0. The next one, 1 over x, well, if I start at 0, 0, that would be dividing by 0, which is illegal. So it starts with a black hole at 0, 0 and force field lines going to the left and the right. These are called asymptotes. And for this graph, our graph actually does not touch or cross these asymptotes. So our pattern for growing here is over 1, up 1. But then if I go over 2 and I put 2 in here, it would be 1 over 2, which is 1/2. And then it would be 1/3, 1/4, over clear to here to 1/10. So I know what it's doing to the right. What's it doing going up? Well, if I go over 1/2, it goes up 2. So over 2 up 1/2, over 1/2 up 2. And then as we go, it gets closer and closer and closer to that asymptote. Remember, it does not touch or cross. Then can I put any negative numbers in there? Yes, I can. So if I put -1 in there, it would be 1 over -1, which is -1. That's why it's over 1, down 1. And then it does the same thing, over 2, down 1/2, over 1/2, down 2. And this branch looks exact. It's a mirror image of the other branch. It gets closer and closer and closer to the asymptotes, but does not touch or cross. And make sure you don't like bounce it off and make it come in here like a C. Make sure it's actually getting closer to that axis, but not touching or crossing. And then for domain and range of these guys, if I go from the left, I start with an arrow. I go to this and it's zooming down. So then I have an open circle, which means it does not touch 0, and then it starts again and goes to an arrow again. So what this means is, since it's arrow to arrow, it's going to be all real numbers, but it takes this jump over this hole here at 0. So it's all real numbers except, and domain is x, so x equals 0 because it jumped over 0. A range does the same thing. I go from an arrow on the bottom, and then I have to jump over my asymptote. So range is also all real numbers except, in this case though, range is y, so except y equals 0. Next one is x to the third. So this one, again, like many others, like these first two, has a start point at 0, 0. Then if I put 1 in, 1 to the third is 1. But if I put 2 in, 2 to the third, 2 times 2 times 2 is actually 8. So that goes up pretty fast. Can I put in -1 here? Yep. -1 times -1 times -1 is -1. And then -2 times -2 times -2 is -8. So this makes a squiggle. And if I do domain, arrow to arrow, left to right, so all real numbers, and bottom to top, arrow to arrow, so all real numbers. I'm going to scooch over to this one here because this is cube root. Cube root and cubic are inverses. So they both do start at 0, 0, and then they actually both have 1, 1, but that's where the similarities, well, 1, 1 and -1, 1, but that's where the similarities end, because after that, these are inverses. So while this one, the cubic, goes over 2 up 8, cube root goes over 8 up 2. So you really only have to remember cubic and then remember that the root does the opposite. It kind of looks like the root. See how it kind of looks like almost like a, maybe that's just me. This one has the same domain and range because it goes from arrow to arrow, so all real numbers and all real numbers. Last one is the square root. So I can take the square root of 0, that's 0. Can I take the square root of 1? Yep, that's 1. I can't take the square root of 2 or 3 because they're not perfect squares, but I can take the square root of 4. The square root of 4 is 2. The next perfect square is 9, and the square root of 9 is 3. Now, can I take the square root of negative numbers? Hopefully you remember back from chapter 4 that square root of negative numbers include imaginary numbers, so there's actually nothing to graph over here. So this one goes like this, and it does kind of look like half of this, but just laying down. So it is the inverse of the quadratic, but only the positive half because there's no imaginary numbers there. Okay, so this one also has a weird domain and range. So if I move from the left to the right, it doesn't look like it starts until 0. So domain is x, so I'm going to have x and 0. And then where is it from 0? Is it on the right or the left? Well, it's on the right, and if you look at these numbers, they are bigger than 0, so it needs to be greater than 0, and it actually does touch 0, so it needs to be equal to 0 as well. Y, for range, same thing, bottom to top, so there it looks like it's starting at 0, and it's above 0, so y is greater than or equal to 0. Okay, now keep these 6 shapes in your mind as we move over and talk about this back part over here. So on this back part, what we need to do is match our equation with its graph. So the first one that I see here is a cube root. So that looks to me, the cube root is the sideways squiggle. So I want to find some that make a sideways squiggle. So if I look at this, it looks like this one makes a sideways squiggle and this one makes a sideways squiggle. So I'm looking at these two right here. This one, if I look at the transformations underneath here, this is going left because it's subtraction, 3, and down 4. Then if I skip over, I find my next cube root over here. this is going right 4 and up 2. It also, this 5 out here makes it have a vertical stretch of 5. So this one is going to be stretched. This one is not. So if I look at these two, which one looks like it is stretched? It's definitely this top one. This one looks more like my original one, and this one definitely has a stretch to it. This one also looks like it moved from 0, 0 to the left and down. This one looks like it moved to the right and probably up. That's probably about it. So this one is number 4, and this one is number 1. I'm going to cross those off now that I have them done. Okay, number 2 is a square root. So if I look for my square roots, looks like my graphs are here and here, and number 2 and number 9. So if I look at my transformations, this one went right 4 and up 5. This one has a vertical stretch of 3, left 2, and up 2. Remember, out in front is vertical stretches and compressions. Underneath is right and left, or sometimes this is inside parentheses, and afterwards is up and down. Inside does the opposite of what you think. So when it's a plus, it moves left. When it's a minus, it moves right. And up and down, pluses go up, minuses go down. Vertical stretches are bigger than 1. We might have some compressions when they are smaller than 1. So if I look at these two graphs, here and here, which one of them looks more like the one we graphed on the other side, and which one looks more stretched? Well, this one definitely looks stretched, so let's check and see if it also looks like it moved left 2 and up 2. It does, so I'm going to go ahead and call that one number 9. And this one then will be number 2. Does it look like it went to the right and up 5? Yes, right 4 and up 5. Okay. Let's go to this next one. This is an absolute value graph, so it should be the V. So it looks like these two are right here together. This one, this 4 out here is a vertical stretch of 4. Inside it's left, so that means, or it's inside it's minus, so that means it's going right 2. And minus again, down 2. My other absolute value graph is right here. Okay, so now we have a 1/4 here. That is a vertical compression, meaning it's going to get wider. It's going to get wider. So vertical compression of 1/4 plus 2 is going to go left 2 and up 2. So if I look at these two, the stretch should be skinnier and the compression should be wider. So this one is definitely skinnier. So that's 3. And this one is wider. So that's number 6. Let's just double check that this one went right 2 and down 2. Yep. And this one went left 2 and up 2. Yep, sure did. Okay, next one down here, 1/2. So that is a vertical compression. So this one should be a little bit wider. Right 7 and up 2. And this is a cube root, or a cubic, so it'll be a squiggle going up and down. So right here, this squiggle going up and down. So I've got 2 here. Well, looking though, this one, the right side goes up, and this one, the right side goes down. So if I'm looking at that, the right side switching, that tells me this one has a reflection over the x-axis. Because anytime it switches and what should be going up is now going down, that means I have a reflection. So in the equation for this one, I should have a negative immediately after the equal sign. So if I scan here, here's my other cubic. Yep, there it is. Reflection. So that negative right there is a reflection over the x-axis. It's got a vertical stretch of 2, left 1, and down 4. So is that what this one is doing? Left 1, down 4, vertical stretch of 2, and a reflection. Yep. So that's number 8. So this one will be number 5. Next, I have this fractiony one. So that's going to be one of the reciprocal graphs. So they are the ones that have 2 branches that have a black hole in the middle with asymptotes going up and down. This one, right and left, is going to be on the bottom, the denominator of the fraction. So this is right 5 and down 2. Where's my other one? Here it is. This is left 4 and up 4, with also a vertical stretch of 3. So the easiest way to tell on these ones is the right and left. So which one of these two looks like it went right 5 and down 2? I think definitely this one. So number 7. So let's double check on 12. Did it go left 4 and up 4? Yes, that one's number 12. Okay, last two are my parabolas, the squareds. This has a vertical compression of 1/3, so that one's going to be wider. This one has a vertical stretch of 5, so that one's going to be slimmer. This has a right 4 and an up 2 on number 10. Number 11 has a left 7 and down 3. So let's find our two square roots. Excuse me. This one definitely went left 7 and down 3, so let's make sure, yep, that looks stretched. It's a little skinnier, so that would be the stretch. And then this one looks wider, so that would be the compression, and it did move right and up, so number 10. There we go. And then down here, identify the domain and range of each and then sketch this. Okay, so if I use these like transformations, that's what they are. So I'm going to tell you what transformation this is. So after all those transformations that we've done, if I see a -2 underneath that, I know this is going to the right 2. And this +4 up here, I know this is going up 4. So this is a square root. So I flip it over back over here. The starting point for this is normally at 0, 0. Transformations, though, right, left, up, down, change my starting point. So my starting point used to be at 0, 0, but I've moved it to the right 2, so that will make it go 2, and up 4. So it's moved to the right 2 and 1, 2, 3, 4. There we go. Then I use my same pattern for growing. Right 1, up 1, right 4, up 2, right 9, up 3, and there's my square root graph. Then when I do the domain, going from left to right, it looks like it begins at 2. So x begins at 2, and then it's to the right of that, so greater than or equal to. And then my range, or my y, it begins at 4, and then it's above 4, so greater than or equal to. Over here, this one's a little bit more challenging. Okay, so I have a vertical stretch of 2. I have left 5 and down 3. So my starting point is usually at 0, 0. Which one of these changed my starting point? Well, left and down changed my starting point. So my starting point is now going to be at -5, -3. There we go. My normal pattern for growing is over 1, up 1, over 8, up 2, left 1, down 1, left 8, down 2. And I wrote this out this time because this vertical stretch of 2 changes something over here. Do you remember if it's the ups or the overs? Hopefully you remember it's the overs. We need to multiply them all by 2. So I'm actually going to go up 2 and up 4. So from here, I'm going to go right 1, up 2, right 8, up 4, and same thing on the left. So left 1, down 2, left 8, 8, down 4. And then I'll draw in my squiggle, stretch. This one is nice, though, because its domain and range never change. So there's a couple answers for you. The domain and range will always be all real numbers on this one. Please let your teacher know if you have any questions.